Greetings, welcome to this new video about mesh analysis method. Solve the problem number 3. Given the electric circuit with R1 4 ohms, R2 2 ohms, R3 1 ohm, R4 5 ohms, and we have two voltage sources V1 8 volt and V2 6 volt. The question now is using mesh analysis method to calculate the current I. The current I is the current through the resistor R3. Let's go to the solution. Let's start first with the mesh number 1. By applying Kirchhoff's voltage law in mesh 1, we can write R1IA plus R2IA minus IC plus R3IA minus IB plus V1 is equal to 0. By replacing the resistors and voltage with their numerical values, we obtain 4IA plus 2IA minus IC plus IA minus IB plus 8 is equal to 0. If we continue simplifying this equation, we obtain 7IA minus 2IC minus IB plus 8 is equal to 0. After we finish from mesh 1, we go now to mesh 2. By applying KVL in mesh 2, we can write negative V1 plus R3 IB minus IA plus V2 plus R4 IB. By replacing the resistors and voltage with their numerical values, we obtain negative 8 plus IB minus IA plus 6 plus 5 IB is equal to 0. If we continue simplifying this equation, we have negative 2 minus IA plus 6 IB is equal to 0. Now we go to the last mesh, mesh number 3. By applying KVL in mesh 3, we can write R2 IC minus IB, IC minus IB plus R5 IC minus V2 is equal to 0. By replacing now the resistors and voltage with their numerical values, we obtain 2IC minus IA plus IC minus 6 is equal to 0. Finally, we obtain negative 2IA plus 3IC minus 6 is equal to 0. Finally, we obtain three equations which are necessary to find IA, IB, and IC. Let's start with equation number 2. We have negative 2 minus IA plus 6IB is equal to 0. Then we can write IB in terms of IA. IB is equal to 2 plus IA over 6, and I will call this equation A. I go now to equation number 3. We have negative 2IA plus 3IC minus 6 is equal to 0. Then I can also write IC in terms of IA. IC is equal to 2IA plus 6 over 3, and I will call this equation B. By substituting A and B in 1, we derive an equation that exclusively relates to IA. We need to put this equation in common denominator. That means we need to multiply here by 6 and here by 2 and here by 6. Then we obtain 6 multiplied by 7IA over 6 minus 2 multiplied by 2IA plus 6 over 6 minus 2 plus IA over 6 plus 48 over 6. If we continue simplifying this equation, we obtain 42IA minus 8IA minus 24 minus 2 minus IA plus 48 is equal to 0. Finally, we obtain 33IA plus 22 is equal to 0. Then we obtain IA is equal to negative 22 over 33 is equal to minus 666.6 milliamps. We go now back to equation A. We have IB is equal to 2 plus IA over 6. Then we obtain finally IB is equal to 222.3 milliamps. We go now to equation C. Equation B, we have IC is equal to 2IA plus 6 over 3. We obtain finally IC is equal to 156 amps. We know that I is equal to IA minus IB. We obtain finally I is equal to negative 888.9 milliamps. After we finish calculation, we have done simulation using SPICE simulator in order to verify our calculation. Let's go take a look in SPICE environment. Here is the circuits done by SPICE simulator. We can see here, this is R1 is 4 ohms, R2 is 2 ohms, R3 1 ohm, and we have voltages, source V1 is 8 volt, R5 is 1 ohm, V2 is 6 volt, and we have R4 is 5 ohms. We go to analysis, DC analysis, calculate nodal voltages. We can see here that IA is negative 666.67 milliamps, IC is 156 amps, and IB is 222.22 milliamps, and finally I is negative 888.89 milliamps. Those are exactly the value we have done by calculation. Thank you for watching this video, and if you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will try to answer you as soon as possible. If you like this video, don't forget to subscribe and to share this video. Thank you again, and see you next time in another example about mesh current method. Have a nice day. Bye bye.